Okay, so now I have essentially the shape of all of my data models, and now I actually need to implement them. I need to use the proper SQLAlchemy syntax to do everything that I need to do. And so the first thing I do as I start to go through all of these different fields is I think about whether or not it needs to be defined as a relationship. So is this a reference to a different table, or is it something that can be kind of a literal thing in that field? And so in a lot of cases, this is a pretty straightforward decision. So what I'm going to do here is I'm going to start with the title in Chinese. So just like for my ID, I need to say mapped data type to a mapped column. Okay. So here I'm going to replace my 3 periods with mapped, and this is going to be a string because this is a literal reference or a literal value. And I'm going to say my mapped column is going to be a string, and I'm going to limit this to 255 characters. Now, this limit isn't strictly speaking necessary, but that's what I'm going to do here just to kind of control the size of the database. Now, essentially, my English and Pinyin columns are going to be exactly the same. So I'm going to go ahead and just replace this. Now, technically speaking, English and Pinyin are always going to be longer than Chinese. So I could extend the length here, but 255 characters is going to be more than enough regardless. This is actually the only 3 fields in this particular table that is not a relationship to another table. Because remember, period of composition is going to be a reference to my time periods table. Date of composition is the dates table. Authors to people, additions to additions, and so on and so forth. So let's go ahead and get these things set up. So this period of composition, I need to make a reference to my time period table. And the way this looks in SQLAlchemy is I do mapped, and then inside of this mapped, instead of specifying a Python data type, I specify the name of my data model. And I have called it time period. And then I say this is a relationship. And then I need to specify how I want this relationship to behave. And in this particular case, I want it to say back populates. And this is going to be a reference to one of the fields in the time period table. And I want it to back populates works. So what this means is that if I add a time period to my works table, I want this to automatically go into the time period table and add that work to the works field, right? So if I go to period of composition, I go to time period. If I come down to my time period table, or my time period model, excuse me, and where is that? It's down here. Okay, so here is the time period table. I have this works field. And so this is the field that I want these 2 things to kind of interact on. And so here, I can actually then define this particular field. Now, I want to say also that this is mapped, and this is going to be mapped to work. But there's something important here. What's the nature of this relationship? I want to allow a time period to be associated with multiple works, okay? Now, I could also associate a work with multiple eras because it is conceivable that maybe I don't know for sure what period a work was written in, or maybe I want to keep track of both Ming Dynasty and late Ming Dynasty and Chongzhen era, all of these kinds of things. But for the moment, I'm going to leave this as a one-to-many relationship, okay? And so the many needs to exist in the works field here. And so in order to specify this, I'm going to make sure that this knows that this is going to be a list of works. And so what this is going to do is this is going to cause SQLAlchemy to generate a relational table that associates these 2 things with each other, okay? And so I'm going to say my works is a mapped list works, and this is also going to be a relationship. And in this relationship, this is going to back populate period of composition. Okay, and this needs to be a string here, just like that. Okay, so essentially this says go look into this work model and make sure that if I add a work here, that then that gets added to the period of composition field in the works table. Now I need one other thing to associate these two tables with each other, and that has to happen up here in the work table. And I need to specify the ID of the period of composition. And this is basically a foreign key that tells these two tables that they need to be related to each other. And so I'm going to say the period of composition, there's going to be an ID here, and this is going to be mapped, and this is going to be an optional integer because I don't always know if this is going to exist. And then I'm going to say that this is going to be a mapped column, a foreign key, and this is going to be time periods .id. Okay? So these are the two things that we need to kind of make this one-to-many relationship happen in this table. Now I want to come here and think about the nature of the date of composition. So remember, the reason that I have a separate table for these dates is I kind of want to acknowledge the complexity of trying to situate these works in time. Because sometimes I have exact dates in mind, but sometimes I also have earliest dates, latest dates, and I want to allow for a work to be associated with multiple different dates. Now, this date of composition field is going to be a many-to-one relationship, and maybe I would make this plural and I could call this dates of composition. But I'm just going to go ahead and leave it as date of composition, and we're going to go ahead and make this a many-to-one field, because essentially what I want to do is I want to allow this work to have multiple dates, but for each of these dates, it's going to be a unique thing in the database because it is specifically associated with a work, or later, as we'll see, with an addition. So here, what I'm going to do is I'm going to say this is going to be mapped, and because this is many to one, it's going to be a list, and then this is going to be date. And then this is just going to be a relationship. Now, I don't actually need or really want a back populates here because the date itself isn't ever going to be used to reference the work or later to be referencing an addition. Now, sometimes I might want to query based on works that are, conceivably written in a range of dates, but that's going to be built into my query logic, and it's not going to be something that needs to exist on the level of the database. Now, one thing I might want to do, though, is because these dates are tightly associated with a specific work, I might want to actually tell the database what happens if I delete a work from my database. I want the database to be able to automatically then go in and delete the associated dates, because if I don't, they're just going to be kind of hanging out anywhere without any association, and they're just going to be taking up space and maybe causing issues. So one thing I can do is I can actually say cascade all delete orphan. And so what this will do is that if I just happen to delete the work, it's going to go in and delete the associated dates. Now, the next thing I want to do is I want to associate this work with an author. And of course, this is an optional thing because maybe I don't know the author of a particular text. But what I want to do here is I want to define a many-to-many relationship, because the key here is that a work can have multiple authors, and an author can write multiple works. And so in order to actually do this in SQLAlchemy, it's going to require a little bit more logic than just kind of doing this mapping and relationship setup. We actually need an intermediate table, a secondary table, to keep track of this many-to-many relationship. Let's go through what this process looks like. So for my authors, what I'm going to do is I'm going to go ahead and get this started, and I'm going to say this is going to be mapped. This is going to be a list of people, a list of person, excuse me, and there's going to be a relationship here. And this is going to require me to define a secondary table. And I'm going to go ahead and name this table I don't know, I could do it author work table. And in fact, let's do it that way. Author work table. Okay. Now this is not defined yet. I'm going to go ahead and do this at the top of my script here. So kind of between my base class and my other classes. Now here, I'm just going to go ahead and add a little bit of commentary, models defined below, just for my own sanity here. And then above that, what I'm going to do is I'm going to start defining my association tables. Okay, so association, these are the secondary tables are defined here. Okay, and so I have this, what was it? I think I called it the author work table. And so this is going to be the table that contains data about this particular relationship. And so this is a table. And I'm going to say that this is author work table. So this is where I'm defining the name of the table as it's going to exist, or I'll say author work relationship. This is going to be the name of the table when SQLAlchemy creates this database. And this needs to contain base metadata. This just makes sure that all of the metadata is tracked properly. And it's going to have two columns, column 1 and column 2. And this is going to be where these two tables kind of get linked together. So in the first column, I want a work ID. And this is going to be a foreign key. And this is going to be works.id. And I want to make sure that there is a unique relationship between a work and an author, because I don't necessarily, want to say, Wu Chang'an and Journey to the West can appear multiple times in the database. I only want that association created once. So to do that, I'm going to say primary key is true. And then here, another oops, sorry, I already have my column object here. And this is going to be my person ID. Okay. And then here, this is going to be foreign key, and this is going to be people.id, right? So this references the name of the table, and then it gets the value from that column. And again, this is also going to be primary key is true. So now that I have this author work table defined, whenever I associate a person with this work, that data gets created inside this author work table. But the great thing about SQLAlchemy is I don't actually need to directly work with that table. I can just work with this particular field in my object. And so that's a really, really nice thing. So now this is just going to be a list of authors. I've defined this. So now I have this relationship through this secondary table. But now I also want to make sure that this exists in my person model, right? So I want this reference to exist there as well. And so I want to say backpopulates. And this is going to backpopulate the field that I called associated works or authored works, right? So I'm going to say authored works exists right here. And so now when I add an author to this works model, it automatically goes into people and adds it to their authored works. This also means that I need to define this relationship on the side of the person, okay? So what I'm going to do is I'm going to come in here to person in authored works. I'm going to go ahead and just do this, and this is going to be a reference to work, and this is going to be backpopulates authors. So that way, if I do the same thing on the side of the person, then it's just going to have that automatic relationship. Okay? So now let's come back up here to our work again, and we're getting very close to being finished with this. So let's start thinking about how we ought to handle additions and the relationship between works and additions. Now, when I first was thinking about doing this, I thought, well, this is going to be a one-to-many relationship, right? There is a work, and it might have multiple additions. But I think it's worth maybe thinking about this a little bit more carefully, because maybe an addition can contain multiple works, right? There are compendia that we can think of as an addition that then contain many, many different works. So maybe we want to allow for this complexity to be, addressed within our database. And so in this case, this means making another many-to-many relationship. And so the process looks exactly like what we just did. So let's go ahead and do this. So here we'll do mapped, and this is going to be a list of addition. And this is going to equal a relationship. There's going to be a secondary, and this might be a work addition table. And back populates works. Okay. Now I need to define work addition table, and I'm going to kind of just do this quickly by copying this. This is dangerous because it's easy to forget to change something, but we're going to just be careful. Work addition table. And we're going to say here, work addition relationship. And this is a work ID, and then this needs to be addition. And additions. Okay, so that should be the work addition secondary table. And so we've defined this on the works. And then let's go ahead and do this for the addition model. We just need to make sure that we flip these. And now we have our additions for our works linked up with each other. Okay? And so then we need to do the exact same thing for categories. And here again, we have a many-to-many relationship, right? Because a work can have a bunch of different categories, and a category can, of course, contain many different kinds of works. So I'm just going to do this really quickly. We've covered this, so I'm going to kind of fast forward through this section. All right, now we actually have all of our work filled out. And so we can move on to additions, but really quickly, let me make the other side of this relationship explicit in the categories data model. Okay, so now we need to start doing the same thing for our additions data model. So we want our research ID. This is going to be mapped a string. And again, here we could basically just say mapped column string, and we could give it a limit. Let's just say 255, although actually it doesn't need to be anywhere close to that because in fact our additions, these numbers right now only go up to like, 45,000. So, here we could actually just say, let's make this, 50. Doesn't matter that much. But again, we have our Chinese pinyin in English. So I'm just going to go ahead and copy this because this is just the exact same thing. Now for period of publication, we just need to do the same thing we did for works, except we just need to make the association with the addition table instead of the works table. So here, I'm just going to go ahead and do this mapped time table, map time period, relationship back populates works. And I'm going to bring that down here, but make sure that this back populates additions. And I'm going to go ahead and do a period of publication. And this is going to equal our mapped optional int. This is a mapped column, foreign key, and this equals, again, time periods.id. Okay? And let me double check time periods ID. Okay. So let's go ahead and again do the same thing with dates that we did in the works model. And I'm going to go ahead and do The same thing here. In fact, I don't actually need to change anything here from the date of composition. So I'm just going to stick that right there. I'll make sure I have my M. So I have my dates. And so now I need publishers, editors, and commentators. So here I need more secondary tables to accommodate this information, just like I did for authors at the work level. Now I could also include authors here if I thought that authors might exist at the edition level in a way that's distinct from at the work level. Again, this is another place where you could have, I think, a meaningful debate about the nature of this data. But for the moment, I'm just going to go ahead and do separate tables for publisher, editor, and commentator information. I could make this a little bit more generic, but I think this is a reasonable way to go about it. And so here I'm going to go ahead and grab this just for the sake of speed and kind of make these adjustments. So now all I need to do is I need to say secondary here. I'm going to say this is going to be a publisher edition table. This is going to be backpopulating this should be published works. And then we need also a editor edition table, a commentator edition table. And then here, this needs to be edited works and, edited. And actually, this should be published editions. And this should be edited editions. And this should be commentated editions. So remember, all of these are referencing fields in the person table. And now I need these secondary tables, the association tables. So I'm going to go back up here and I'm going to go ahead and define these association tables. And so this is very similar to our author work table. So I'm going to go ahead and just grab this table definition here. And this is going to be a publisher edition table. And I'm going to go ahead and do this for all of these. And now, actually, the next two tables are basically the same thing. And say this is the editor and the commentator. Now, note because of all the duplication here, it might actually make sense to just have a generic person to edition table and then store all of this information in this particular table. But I kind of like to have that separation just for my own, for my own purposes. So now what I'm going to do is I want to make sure that these relationships exist where they need to exist back in our models. And so here we have editors, edited editions. We need to make sure that we have these kind of defined back in our persons table. So here we have, this is publisher edition table, and this is backpopulates publishers. And then we'll do the same thing here for editor. So now we have our editorial information, commentator information kind of inserted in here. Now my database or my spreadsheet doesn't actually contain this information, but it is useful to be able to keep track of this. And so I want to eventually add this information to my database. All right, so we come back to our editions. You have publishers, editors, commentators, character set. Okay, so here when I'm defining my character set, I have some options. And basically I just want a mapped string here. And I want to specify that this is going to be a mapped column. And this is going to contain a string that is, no more than, probably 50 characters long, because it's just going to be traditional, simplified. Maybe if I wanted to, if I eventually had Korean, I would want to specify that. If I wanted, Japanese character sets, I could add those things. But this is what I am going to do for the moment. Now, one thing that I could do if I were being very kind of sensible about how I'm doing this is I could put a constraint on this field, because I don't want somebody to accidentally put in traditional but misspelled or simplified but misspelled. I want to make sure this is consistent. There are a variety of ways to handle this. If you're using a kind of database software that allows for enums, you can do that. That's basically a way of kind of constraining the options for a particular field. SQLite does not allow that. It does allow you to put a constraint using the check constraint class on the values that go into it. Or alternatively, you can use a separate table to contain the character set types and then use the ID to that, right? But for the sake of what we're doing right here, I'm just going to leave this as a string mapped column. If you are curious about the check constraint, and actually I can go ahead and add it in this particular case, because it is a useful thing to at least know how to do. So I need to make sure I'm importing check constraint from the SQLAlchemy library. And then I'm going to kind of come back down here. In this character set field, I can actually check the constraint. Again, I'm only going to do this for demonstration purposes. There are other fields in this database that it might be sensible to do this for, but for the moment, I'm just going to do it right here. So what I want to do is I'm going to use check constraint, and just for readability, I'm going to put a new line here. And the first thing I want to say is in this column, which is called character set, what I want to do is I want to check, is this value in a list of traditional or simplified? And so what this is going to do, and then I need to actually provide this with a name, and this is a check character, oops, I prefer underscores, check character set value. Okay, so basically this just ensures that anything that ends up going into this particular field is either the string traditional or the string simplified. Okay, but again, I don't really want to get too deeply into that, just because it's kind of, it'll just extend the time for this video, which is already going to be pretty long. So I also want to specify what corpus this addition is found in. I basically want to reference one single corpus. So here, this is going to be mapped corpus, and this is going to be a relationship, and back populates is additions, because I want to make sure that the corpus is keeping track of the additions that exist in that corpus. And I also need a corpus ID, and this is going to be a mapped int. Now I could make this optional, but actually I don't want this optional, because I always want to be sure I'm tracking the corpus that these documents came from. Actually, I tell you what, I am going to make this optional, because maybe I have metadata for a text that I don't actually have a digital copy of, and I want to allow for that possibility. That's not actually the case in this instance, but, a little bit of future proofing never hurt anybody. So the map column is a foreign key, and the foreign key is going to be the corpora.id, right? So it goes into the corpora table and grabs the ID. So now we have this relationship set up. For the origin corpus ID, this is simply going to be a string. And I'm going to say 255 here. And then notes is going to be also a string, but I'm not going to limit the length. Okay. And so now that wraps up our addition data model. I'm going to go ahead and make sure I have this association with the additions in my corpus data model really quick. So corpus data model. So this is going to be a reference to addition, and this backpopulates corpus. So the next step is actually going through my data models and just quickly specifying the data types, because I've done most of the relationships. There are still a few to define, but let's just really quickly kind of do the literal fields. And first I'll define the data types and come back and decide which ones should be optional. Okay, so now I have all of the remaining literal fields filled out, but I also want to kind of go through and make sure that I'm not requiring things that don't need to be there. So for example, the title Pinyin and title English, I don't want to necessarily always have to define this. So here I'm just gonna simply make sure that this is specified as optional. And here to do this, I'm just gonna go ahead and copy this to make sure I can quickly do this. One thing to be aware of is these the relationship tables are by default optional. It doesn't necessarily require that they have to be there. I want to make sure this is required. The character set's required. Corpus ID is required. Notes are not required. Here, the Pinyin name of the person I think is not going to be required. And then the CBDB ID, I don't think I want to require that either. Again, Pinyin and English don't need to be required. Type of category is required because I definitely want to enforce kind of a specification for these categories. Here for the corpora, I'm going to make the URL specification optional. And then time period here, Pinyin and English are optional. And I need to come back and fill out this additions link here in a second. We'll come back to that. And here for the dates, I would basically say the Chinese style date's optional. The date type and precision, I guess these can be optional for now. Let's leave them. Let's make them optional. And then the year, maybe I'll require a year, but not a month or a date, because in a lot of cases we don't have months and dates, and it doesn't always make sense to kind of localize things that specifically. Okay, so there we have it. I think that's everything except the additions in the time period. So here, this basically just does the same thing as the works does, except we want period of, I think I decided this was period of publication, which is distinct from period of composition. It's a little bit hard to, know for sure which is which in certain cases, but that's fine for this. Okay, I think that basically takes care of our data model. So I'm going to clean this up very slightly in that I'm going to get rid of my periods here because we don't need these. And now I'll save this. And so essentially, assuming that I don't have any typos, which I'm sure I do, or I don't have any bugs, which again, there almost certainly are, we're ready to actually create our database. Now, in order to do this, it's quite simple. We actually haven't interacted with SQLAlchemy beyond kind of its ORM model defining stages. So now what I want to do is I want to actually specify that if you run this code, what I want it to do is I want it to go in and create this database with this schema definition. Now, this might require a few tries depending on whether or not I did a good job with this. But let's just see how it goes. So here, I basically want to say, if I run this as the main file, that is, if the namespace is main, then I want to do a few things. I want to load in my database, and I want to create the schema. Now, in order to do this, I need to actually import a few new things at the top of my code. And so right now, we just have all of these kind of relational defining things. But what I'd like to do is I'd like to actually kind of import the stuff needed to run the database. So here I'm going to say from SQLAlchemy, import create engine. Okay, now we're going to import a few other things in a minute, but this is good for now. So I'm going to come back down here to the end of my script, and I am going to go ahead and say that my engine is going to equal create engine, and I'm going to specify the name of my database. And here I just get to make it up. I am using SQLite. If I wanted to just run this in memory, I could leave it as SQLite like this, but I'm going to go ahead and create a bibliography.db. And in this bibliography DB, I'm going to say echo equals true. This basically will just kind of show me the SQL that's being generated to create my database. And then I'm going to say base.metadata.create all, and then I am going to give it the engine. Okay? I'm going to save this, and now if I run this code, assuming I don't get a million errors, it is going to then show me what happens. Okay? So now I'm going to say Python bibliographic. Oops. The first thing I need to do, of course, is I need to go into this database video folder where my code is living. And then I say Python bibliographic database.py. And it says, cannot import name declarative base from SQLAlchemy.orm. That is because declarative base is not spelled correctly. That's a bug that was from the very first few minutes of the video. Okay, so here, let's take a look here. So we have an issue with our mapped column foreign key at time periods.id. Additional arguments should be named dialect name argument got foreign key. So let's go ahead and take a look at what I've done here. And did I map column foreign key? Oh, yes. This again is another early bug, and I'll make an annotation for this. But map column time periods in our, this is an addition, right? It shouldn't be foreign key equals, it should be foreign key with parentheses, right? Mapped foreign key, right? This is a function and not a parameter, okay? And, oops. I also need to be very careful to make sure I'm typing English parentheses and not Chinese parentheses. And there we go. Okay, so foreign key associated with publisher edition relationship edition ID could not find table edition. Okay, so this is because it's editions. So I'm going to look for edition.id, and this should be editions, and I need to fix that here, everywhere that exists. Okay, save it and rerun it. Okay, that worked. So now we have our database created.